Okay, now moving on to the soluble salts, I will tackle the soluble non-spar salts, which means we're going to go through the process of DFEC. Some of you will be probably wondering what does D stand for, what does F stands for, what does E stand for, and what does C stand for. So just a recap for you. Okay, so your D stands for dissolution, or in layman terms, just dissolve. F stands for filtration, E stands for evaporation, and C stands for crystallization. Now, I think it may seem hard that you would have to memorize this DFEC, but if you understand the process of DFEC, I think it will be very logical because you are just mainly dealing with acids plus solids that reacts with the acid. Alright? Now, this is a typical DFEC experiment setup. Okay, so I was saying just now, you're just reacting acids with solids. So at the first part, you will find that see, the explanation says extra powder added into acid and stirred. Okay, so the first part is basically using excess of the excess of the powder, so that all the acid will be reacted. Now if you are using excess of the powder, what's going to happen? Just like if you were to dissolve sugar in tea, okay, there will be some point in time where you cannot dissolve the sugar anymore. So the next logical process is for you to filter. Right, the moment you filter, now you must understand that since all the acid has been reacted, and the acid reacts with the solid, there will be a salt form. And whatever the residue that remains here is not really a salt, it's just the undissolved, unreacted excess powder. So the since we are forming this soluble salts, right? So this is actually your soluble salt, which comes down as a filtrate. Okay. Now, in chemistry, we don't normally deal with liquid products, so we want it to be solid. So the next logical step is for you to go and heat it up. Okay, you evaporate half of the water to make a saturated solution, and this is a precursor to your crystallization. Okay, so the moment you saturate the solution by evaporating half of the water, you leave it to cool, crystals will form, and eventually the crystals, if you remember your copper 2 sulfate experiment in lower sec, your crystals will be collected at your filter paper as the residue, after which you just wash it off, rinse it with deionized water or distilled water, and then you'll have your crystals. Okay, so this is in solid form. So basically DFEC is quite logical if you understand it's just between an acid and a solid. Okay, so I have just moved the organization of all these contents around, because you don't have much space. Because what I'm going to talk now is about your actual reaction. Now, for this kind of reaction, for your DFEC, there are only three ways in which you can prepare your soluble non-spar salts, and it involves this excess solid. Now, why is this a solid? Because we are actually reacting acid with an insoluble metal, insoluble base, and insoluble carbonate. So the three reactions as indicated here, I've actually just made a short form for acid because I don't think I have space around here. So this is your acid, right? A stands for acid, and you have your metal, you have an insoluble hydroxide, and you have an insoluble carbonate. And then you realize that all these three categories, metal, insoluble hydroxide, and insoluble carbonates, they are actually insoluble. But insoluble in what? Insoluble in water, right? But they actually react with your acids. So they will form salts. Of course, acid plus metal will give you salt plus hydrogen. Acid plus insoluble hydroxide, this is a neutralization, gives you salt and water. And acid plus insoluble carbonate, you got salt, carbon dioxide, and water. But I'm not particularly interested in your other products, okay? Because remember, our objective is to form soluble non-spar salts. So the moment you have salt form, right? So we're at this stage here. you can take a look at the cursor. You're at this stage here where you already form your salt, and your solids, your metal, your insoluble hydroxide, insoluble carbonate, they react with acid, therefore they dissolve in acid. And then because this is in excess, so you find that the excess is left as your residue. So this is your salt, right, that you form. And I don't need to repeat how you're going to obtain the salts. It's basically through the process of D, F, E, and C. That's how you obtain. However, there are certain salts that you cannot prepare um, using all three methods. For example, I'll just give you a simple example of copper. Okay, if you go back and revise on your reactivity series, you will realize that copper does not react with acids. Okay, even if you warm the acid, even if you react it with steam, copper does not react with acids. So in this case, how is it that you're going to form a salt of copper 2 sulfate? Right, so for copper 2 sulfate, how are you going to form it? You cannot use this first method. Okay, so let me just point this cursor. You cannot use this first method because your acid will never react with your copper metal to give you your copper 2 sulfate. So in this case, your acid here is your sulfuric acid. Okay, but you can actually form copper 2 sulfate using this method, which means your acid, because you're forming a sulfate, is sulfuric acid plus insoluble hydroxide. So in this case, it has to consist of copper, right? So it's copper 2 hydroxide. You'll form your copper sulfate. Then you can proceed on. Similarly, for copper sulfate, you can actually use this reaction, acid, which is sulfuric acid, plus your copper carbonate. Now you realize copper carbonate is insoluble, right? Even for the second reaction, your copper hydroxide is insoluble. So we are actually we are actually following the general rule. We're actually following the correct rule. Okay. What about what about salts like for example magnesium sulfate, Mg2SO4 2 minus, or MgSO4. Now for MgSO4, because if you take a look, you can actually use all these three methods, because to form magnesium sulfate, if let's say you use sulfuric acid plus your metal, which is magnesium, there is a reaction because your metal here is reactive. So for cases like magnesium sulfate, yes, you can form using these three methods. But for copper 2 sulfate, where your metal does not react with the acid, so please be careful. This can extend further by saying maybe silver sulfate or lead sulfate, those that cannot react with your acids. Okay, so basically for DFAC, this is the process.